So, hello everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events. This event is one of such events. So if you want to find out more about the events we have in our schedule, there is a link in the description. Go there, click on this link, and you'll see other events we have in our pipeline. Then if you're watching this video on YouTube and if you want to see more videos like this, more streams like this, there is a red button with subscribe on it. You need to click on this button, and then you will get notified about all our events. And then finally, we have an amazing Slack community. There is also a link in the description. We talk about all data related things. So click on this link and join our Slack channel. During today's presentation, you can ask any question you want. There is a pinned link in the live chat. Pinned link in the live chat. You can click on this link and ask your question. And Arseny, by the way, do you prefer questions at the end or throughout the presentation, during the presentation?
I think some interaction would be useful and valuable for everyone. So I'd prefer to hear the questions and maybe answers to my questions during the talk.
So I will be keeping an eye on the questions, also on the live chat, and I will interrupt you and ask, well, if it's relevant to what you are showing. So with that, let me stop sharing my screen. Thanks again for joining us today, and now the floor is yours.
Okay, nice. Thank you for the introduction. And let me share my screen. Okay, all right. Here we go, using my screen, right?
Yes, all good.
Okay, so today I would like to speak a little about reliable machine learning, about some engineering perspective, how to build machine learning based software. My speech is mostly oriented for the audience of data scientists who maybe not very strong in software engineering, who may lack some software engineering background, but they want to make their machine learning pipelines more robust, more suitable for like real systems that may have some load, some corner cases, etc., etc. So today we are going to cover some things that are related to software testing, and then we'll try to focus more on ML-specific pipelines and ML-specific testing approaches. A bit about myself. I'm a machine learning engineer. I've been working to multiple companies, doing different types of domain problems related to machine learning, mostly computer vision for last years, but not only. These are my contacts. Feel free to send me an email or something later. And also the slides will be shared as well. Okay, so I would like to start with a not that cool story, how I came up with this whole speech at all. Last year, I introduced a bug in Logger, which is not very common situation, I think. And after some time, this bug led to significant outage on several assembly lines on multiple factories and potential loss of 6-digit numbers. And I would think that if someone among our listeners will be able to avoid this bug, such bug in future, it makes my speech useful. And yes, some better testing practices could have prevented it in a very easy fashion. So we will talk about non-ML specific tests, we will talk about ML specific tests, and we will talk about best practices for testing. we will talk a little about runtime checks and overall about this software engineer and test mindset. And we will not talk about stuff that are like purely machine learning focused, like machine learning model evaluation, metrics, validation, and also we will not cover manual testing because that's not how engineers usually think. So obviously, machine learning is not a value itself, but software based on machine learning is valuable. And in this case, we need to make sure our projects are tested from both perspectives, like machine learning one and software one. Here we introduce the idea of defense in programming. This idea is originally introduced in the book by Steve McConnell, Code Complete. And I just would like to read this quote from this brilliant book. So you need to adopt the mindset that you are never sure what other drivers are going to do. And in software world, it means you are never sure what happens to things around you, like other services that use your service, or some third-party data, or your customers, or whatever. Like the world is changing and you never know what you can face. So you should take responsibility for protecting yourself and the system you built, even if it's not your fault. So very first thing that we may need to make our machine learning systems reliable is obviously some testing. When we are talking about software testing, there may be multiple types of tests, like some UI tests, integration tests, end-to-end tests, unit tests, mutation tests, whatever. You can find a lot of different taxonomies that try to separate the space here and there in different manners. I don't think there is one canonical or classic separation. So we will just cover some of those that are most useful for machine learning practitioner routines. In general, let's maybe let's make a step back and try to understand, why do we need tests at all? What are we avoiding with tests? First of all, obviously, we would like to avoid some explicit code errors that may happen in complicated code logic. But that's not the only reason. Another big thing is unintended changes in logic, because, well, when your pipeline is evolving, when it has to interact with other pipelines, you may change your logic even without some explicit intention, for example, during refactoring. And tests help us avoid such situations. If you're talking about tests, it is common to say that there is a pyramid of tests with different granularity. Some are slower, some are faster, some are more integrated with other pieces of your system, and some are more isolated. For example, some UI tests, when you already test the whole UI of the system you built, they usually tend to touch everything in your system. But when we are talking about unit tests, it's usually just testing some very isolated piece of code, some little function or something like this. So unit tests are faster, and these high-level tests like UI tests are usually slower. I would like to introduce a little example, because given we would like to have some real-world examples here, it makes sense to talk about some real stuff. Let's imagine we have a microservice that is doing oriented object detection. So we send some images here, and for these images, we run some machine learning model, object detection model, and we try to find some object, doesn't matter what kind of object here, and we would like to find the bounding box of this object, like a rotated bounding box to make it more complicated, and save this cropped object only. So this is like pseudocode here. We take image from some storage. We run our detected model. We crop the object we found. We rotate the cropped area. And finally, we save the result in the same storage on other parts. Does that make sense?
I'm trying to... So what do we crop and rotate and save afterwards? So first we run detector, but then we crop and rotate. Why not the other way around?
Well, let's say our detector does not only detect this unrotated box, but for example, you would like to detect face like this,
okay,
and would like to save it like this eventually.
Okay.
So
this
just
is a
to make
real life example, right?
Almost. Like I covered some things I couldn't reveal, but it is heavily inspired by real life example. And let's say we have some image storage that has option to get image and save image. And we have this kind of detector that can find some bounding box and also the angle how this bounding box is rotated. That's just an example of domain logic that we will discover later. And of course, we have some functions to crop images and rotate images. These are some APIs that could happen here. And let's try to think how we could introduce some tests for this kind of pipeline. This pipeline is very simple, not the primitive one, but it is still simple. And that's why I think it makes sense to review what kind of tests we can introduce here for this pipeline. So let's start from unit tests. Unit tests, as I already mentioned, are tests that are fast, simple, and as isolated as possible. And usually unit tests cover like single method or single function. In Python world, the default choice to do this unit testing is PyTest library. And let's try to think what can we do. For example, if we have this crop image function, we can consider something like this. We have some artificial image. We have some object on this image, which is effectively a white blob here. And we crop this image and we ensure that our cropped area is white. Very straightforward, doesn't check something complicated, but at least something. And as I said, unit tests should be very as small and as atomic as possible. So we have this test. Let's say we read some image from our fixtures. We'll discuss fixtures later. And we have a single loop and we check the result. What's wrong with this test?
I don't know. Looks okay, except that like there is this for loop. I think it's a bad idea to use for loops and tests. But apart from that, yeah, I don't see anything specifically wrong with that.
That is right. This for loop is not. This for loop makes this test not as atomic as possible. That's why it makes sense to decompose it. So in PyTest, we have this option to parameterize tests, which means we can use different scenarios, different parameters of this function, and make sure that things work with different parameters.
So in the
And
previous
it makes,
example, sorry for interruption. So in the previous example,
yeah,
I think at some point, so we're looping through all these angles, and then let's say, or on angle 35, our test would break, right? And then it will not continue to other, right? To other examples. And we will know from our reports that, okay, it failed on this angle, but we do not know how it performs on other angles, right? That's the main, disadvantage of using a for loop here.
that's one of ideas. Overall, first thing is to know all the use cases. The second one is parallelization. So for example, here we have only 2 samples and the test is really fast, so we don't care that much. But if this test takes seconds and we would like to do our CI on big machine, it makes sense to parallelize stuff so our workers could handle those in parallel.
Yeah, because I guess for this, for the fixed version, it will not have this problem. So it will try to run all these things in parallel, and then it will not stop if one of them fails, right? It will run all of them.
That is right.
Okay. Yeah, thanks.
Okay, so I introduced the word fixture, but I did not explain what is it. And maybe some people in the audience do not know. So very simple, fixtures are some fixed inputs or maybe some expected outputs that are used in tests. So in my example, a couple slides ago, we generate an image here that makes the test very, very naive. But we could also have some specific image with the object we are trying to detect, or we are trying to crop something from, and we can compare it with some expected result. It is very powerful techniques, especially in computer vision field, because, well, it is always useful to use your eyes in computer vision, and thus you can make fixtures and look at them once to make sure you do not screw up with your generated images or something like this.
I have a question here. So
Mm-hmm.
crop image, is this a model inside? So you explicitly didn't show what exactly is inside, so it was just a signature, but usually it's a model inside, right? That does some detection and then, no,
I think
here
crop
you just
is
give it
just,
coordinates, right?
yeah, that's
And then it
right.
crops. Okay. So there is no machine learning, so it's always deterministic. It always.
Yeah, it is deterministic.
Mm-hmm.
Okay, let's go forward. Let's talk a little about integration tests that are expected to be slower. They may affect more components. They would require more maintenance work because once something is changed, you need to tune the test. And usually it only needs, again, PyTest and maybe unit test for some mocks and patches. Again, mocks and patches is something that we will cover very soon. So let's imagine something like this. We generate some request with some path to image. And instead of applying function directly, we emulate this post request to our microservice. And then we check that we have some success and result path is some image. And this image is a JPEG image. So we do not check exact value of cropped object, for example, here, but at least we check that the whole end-to-end pipeline worked and it did not explode and it is successful, etc., etc. And let's talk about mocks. Let's talk about patches. Let's see this code. If someone is not familiar with mocks and the technique of mocking at all, try to guess what's going on here. I will pause for like 30 seconds. Try to guess what will be the output of such code. Anyone wants to guess before I show the result?
So let me check the chat. So there is some delay between the stream and when people actually see it on YouTube. But may I try?
Of course.
So I think I know what the concept of mocking, but I still want to try and see if I got it right. So here we override the behavior of this getAngle function. And we say that instead of returning 42, we wanted to return 0, right? So then we do print getAngle, it should return 0 instead of 42. And then call count, I think, would be 1 because we invoked it once.
Here we go.
Yeah.
Sounds like you're a principal engineer.
Yeah, exactly. That's what principal engineers do, right?
Yes, they can read some convoluted code written by some other person. So why do we even need it? Mocks and patches are very useful for some integration like tests because you can not always rely on some external service. Your external service can be long and unresponsive. Some of such services may require messy input-output operations. They may be slow, and so on and so forth. And in this case, you can replace this component with something that is totally controllable by yourself. Thus, you can simplify your testing flow, completely understanding what's going on and how to control it.
Yeah, we have a question. So the question is about the code snippet you showed, and it's about why would we even want to do this. So I guess here it's more like a toy example. So we wouldn't want to overwrite a call to a function, right, that we just defined. So probably here it's just an idea that we can sort of patch a code, a piece of code that we have, and that's right? So this is not something you would do in real life. What you showed was more like an example of what is possible to do.
That is right. So imagine this getAngle function would be a request for some third-party API that is not always available, and it is slow, and also it charges some significant money for this request. But you would like to be sure that your logic of processing the response from this third party is always stable. So you can, for example, store this response once, store it on your local drive, and then instead of using this call to third-party service, you just read this response over and over and over again.
Yeah, makes sense. Thank you.
PyTest is a very powerful tool. You can do a lot of different checks. I recommend this article to have a look through later. And some examples here that, for example, you can check if some function raises some specific error, like you would like your rotate image function to raise error when instead of angle you send a string, for example. Or you can even check if you have proper logs written after some function is executed. That's a very magic style option, but you have it.
So
Here in yeah, it's weird. It's weird, but actually I had to do something like this once in my real life, because when you do not control the whole system and you cannot see all inputs, outputs, sometimes you can use this log capturing stuff to check if some function you are not in control of is even called or not.
So for example, I can imagine this could be some native library written in C++ that is already compiled, that is doing, like maybe we can take an example of XGBoost, right? So I think it's doing something like that. And let's say it prints something to standard output and you cannot easily do some things. So you just capture the output and then you say, okay, expect this to see in the output. That's right? Or maybe it can be something like that.
Maybe not exactly with this code, because this code is capturing Python logging, not some std out. But overall, the idea is completely legit. So imagine you're using some third-party library that has its own login, but you don't want to mess with this code because, well, it's not your code. You do not own it. And they have this internal login, not std out, but Python log. And you can capture what's going on here. But in many cases, if you have some wish to build such kind of tests, it means the design might be not perfect. Be careful. Okay, so let's say we have some legacy code and we have no tests, which is a very common situation. If you join the team that had not perfect software culture in before, what can you do? Actually, first thing is don't panic. It's okay. It happens to all of us sometimes. It's not a disaster. And you should try to improve the code base gradually, step by step. And you should start with some high-level smoke tests. And once you cover your project with these higher-level tests, you should consider adding lower-level tests. And you should be sure that your tests are always run in CI, always. That's a cornerstone. Because once your tests are not runnable on a regular basis, as they tend to rot very, very, very fast. And if you do not check it every time when you commit, when you push new stuff to your repository, you are going to lose the value of these tests.
I have a few questions. I'm not sure if you you're going to cover it, so you're going to talk about smoke tests. Because I wasn't sure if you covered them before. I think you had an example of a smoke test, sort of, like when you just sent or maybe I'm wrong, but in that example, was it an integration test when you just sent a request to some endpoint and you just see that it didn't die from this request?
Yeah, we can consider this kind of test as a smoke one. Well, there is no clear boundary from my point of view. You can say, well, this is a legit integration test, and I can say, no, it's not. It only checks that we wrote some file. So that's not a real test, it's just a smoke test. The idea behind smoke test is we try to do some high-level integration tests that do not check maybe for every detail, but it is a sanity check that things do not explode. And for script languages, we can say it's something comparable to this code compiles. We will talk more about smoke tests about when we touch training pipelines a bit later.
I have a few more questions. So you mentioned also CI/CD, CI. Are you going to talk about what that is?
I don't think so, unfortunately.
Yeah, so maybe you can say a few words what it actually is. So this is like when you push to Git, I think that runs the tests, right?
Yeah, okay. So CI is kind of a system that is doing some code-related operations on a regular basis. For example, when you push some code to your GitHub repository or GitLab repository or whatever, this system would check for updates, check for new commits, And based on those is triggering some new actions. For example, you can run tests after every commit, or you can build some Docker image with your software after every pull request being matched to master branch or something like this. CI is a very important concept in the whole software engineering world. And I don't know, it's hard to recall how people used to live without it.
Yeah, by not running tests or doing manual tests after each deploy.
Yeah, and manual builds and manual. It was a harsh world.
And then you also mentioned another thing. You said we shouldn't let our tests rot. And what do you mean by letting our tests rot? So what happens when our tests rot?
Well, imagine you build some pipeline, you build some microservice, and you have some tests that are legit, that they work, they cover your project more or less, and you do not run them on a regular basis. It leads us to the situation when there is a chance you introduce some new changes to your main code base. You change some APIs, you change some logic underneath, but you do not run your tests. And thus you can forget to update your tests. I don't know, for example, you introduced a new field in your response, but it's not reflected in your tests. And after a little bit of changes, after some weeks of work on your main code base, your tests are not longer relevant. And if you would like to do some manual tests, manually launch these tests in a couple of weeks, you only see that everything is red, all your tests are failing, and you have no idea how to start fixing it. And you say, well, okay, I will just ignore it. And once you ignore your tests that are like partially failing, you will never recover it, and you lose all the value you could have.
Okay, clear. That's I had a very vivid image in my head while you were explaining this. I think it happened to me.
Nice. Okay, I will cover some exotic approaches to testing, not with proper level of detailization, but most curious listeners could read a little more about it later. So one concept is mutation tests. Mutation tests help us answer the question, who will watch the watcher, who will test the tests? The idea behind mutation tests is very simple. We change our code base in some random way. That's the mutation. For example, we can replace some pluses with minuses. Then we run some tests. And if our tests are still green, it means they're passing. Maybe it's an indicator that our tests are not that great. Because, well, if our code has been changed in this harsh way, in a random way, and tests are still passing, maybe this test do not actually check anything. And one more exotic approach to testing, it's something named property-based tests. The idea behind property-based tests is the following. Instead of testing some particular values, we should test the whole behavior of our code. We test function properties. We can consider it as an evolution. First, we test with some really hard-coded values. Then we test with some randomized inputs, but we check that with different inputs, we follow the logic we try to introduce in the very first place. And finally, you can do it in a more formal way. I would suggest to have a look at this hypothesis library and some manuals about it. It's not the most simple concept, but sometimes it can be useful if you are doing some heavy, I don't know, math heavy or something like this software. Also, a little bit about metrics that are applied in software testing. We can talk about coverage. Coverage is a metric that reflects what share of code base, usually this percentage is calculated line-wise, has been used when the full test set has been run. So imagine we run our test suite and we have some number of lines that were executed, and we can divide this number by a total number of lines you have in your project. It may seem a good metric for start, but again, it's not perfect. It's not a polar star metric because, well, you can build tests that still covers whole code base, that invokes everything, but doesn't test the result at all. So this means that coverage can be used as somewhat informative metric, but you cannot always say that, well, our coverage is X, we're good, or our coverage is Y, lower than some threshold, we're bad. It doesn't work like this. So it's a soft indicator, not a harsh suggestion that if your coverage is lower than something, you should write more tests or vice versa. Okay, another best practice is adding tests when you see a bug. So it's very, very safe approach. Just introducing new tests after the defect has been found and fixed, of course, because every production defect highlights the lack of tests in your existing code base. That's why we need to extend it and verify that defect has been solved and it will not happen again. And CI, yeah, I had something about CI in my slides and I totally forgot it. It happens, sorry. One more thing to consider is about positive and negative tests. When positive tests check that everything is going fine, that's our optimistic scenario. Negative tests tend to check failures, mostly graceful and expected, but maybe some not that graceful. And usually the more experienced engineer is, more experienced engineers tend to write more negative tests because negative scenarios is what really bothers us in big systems. Again, some quote from Steve McConnell. It makes sense to write more negative tests, and it has been proven by some software-related research. So there is a problem named Flaky tests. Flaky means tests either fall or pass from run to run. It's non-deterministic. There may be multiple reasons to it. Like, for example, if we have some randomness in our code and we do not fix this random seed, we can have some race conditions. We can incorrectly design input-output operations related to temporary data. Let's see an example. What's wrong with this test?
We're not fixing the random seed, right? Presumably.
We don't.
Yeah, that's probably, this is where the issue could be, right? So because I assume judging by the name of this random crop function probably does random crop, and then we don't know
Indeed.
which part of the image it would pick up.
Right, exactly. And what's wrong here?
Yeah, I think because there are 42 tests running at the same time. They are probably running in parallel, and they all write to the same location. And then maybe that could be Yeah, because we read from this location, and we don't really know what kind of file it actually read.
Yes, that's right. So we don't do, that's almost right. We don't do 42 tests. We have 2 tests, one with 0 angle and
Okay,
one
so it's
with,
not a range.
yeah.
But
Yeah, it's not range, it's just 2 tests, but the idea is completely right. We get some image. We have different image with different parameters depending on the angle, and we store this image, and then we check some output of this image. And if we have multiple workers running the same test with different parameters, there is a chance of some race condition when our value is overwritten by other tests, and it could be flaky. Again, very common situation in real world.
yeah, it happened to me as well.
I'm not surprised. Okay, let's switch to more software-specific stuff. Let's talk about ML-specific defects. In regular software, bugs tend to be explicit. In ML world, they are easy to hide. For example, try to see this function and say if you have some kind of bug here. It's a single line function, but it's very complicated to check if it is correct or not.
I have no idea.
Exactly, I don't remember as well. The idea of this function is to take this rotation matrix. Rotation matrix is 2x2 matrix that can be used to rotate an image, and it contains of sines and cosines, and with proper signs here and there. And I don't remember its format. And as far as I remember, I haven't seen a person who can recall it without a textbook. So you never know. And for such cases, you always need to have a unit test.
So are there actually bugs?
And I think no.
Okay. I thought there is
as
a bug.
far as I remember. Yeah. But that's not even the most popular kind of problem in machine learning. More popular trends are to use different preprocessing or feature engineering in test and train environments or research and production components, or some numerical problems. We can have overflow or not a number after division by 0. We can have incorrect access and unexpected broadcasting. In computer vision, we often mess with width versus height and X versus Y coordinates. We can have some API mismatches between libraries. Everything is possible. For example, let's see some computer vision related code and try to find out what's wrong here.
The D-size thing, right? It's height and then width, or not?
Yeah, you got the idea. So we take.
Yeah, I think like even before that in the shape. No?
Yeah. So usually when we are talking about images that are in NumPy format, its shape is Y coordinate, X coordinate, and channels, which means heights with channels. But here we unpack this shape in improper way. And when we do this var perspective procedure, we effectively change the shape. And if we have this kind of assertion, we will catch it.
Yeah, the only reason I thought it could be a bug is because you just mentioned before that slide that we sometimes match X and Y.
That's very popular thing. But let's try to make up some tests that are very specific to machine learning pipelines. For example, in data preprocessing, we often have some functions that convert things back and forth. Example of such function in our context, when we have some rotated object detection, we can consider functions that convert radians to degrees and degrees to radians. And we expect some consistency that x is equal to inverse function of x. So if we take degrees and convert to radians and then convert to degrees back, we have the very same thing that we used as int. But also in some cases, we would like to have some additional invariance. So with our detector example, if we slightly change the image, we expect to have almost the same result as we had before. Not exactly the same, but almost. That's why we have this epsilon in this formula. For example, in this computer vision world, we may expect our model to be invariant to some image rotation, to partial occlusion, to perspective shift, like when we change our camera a little bit. We can consider some lighting conditions. We can expect some weather artifacts if we are talking about images from outdoors. We can expect camera artifacts, etc., etc. Another place where invariance happens is sentiment analysis. For example, in these two sentences, we would expect that changing the name of subject does not affect prediction in terms of sentiment analysis, because, well, name is not something that changes the sentiment here. And also, we may expect some changes to change the model prediction as well. Like here, if we have this, I like this show and I don't like this show, we obviously would like to have positive sentiment and negative sentiment. And this we can artificially add negations to some test subset of data and make sure that labels are inverted. Like you change your I like something to I hate something, and you expect labels to be inverted. More technical stuff that often happens in machine learning world is related to different environments. So let's say you built some machine learning model and you expect it to run on mobile, on cloud backend, and you use CoreML for your iPhone, and you use Onyx runtime for your backend. And in this case, we would expect to have the same outputs from both models converted to CoreML and converted to Onyx. And that's how we test. We have this image, we have this CoreML model, Onyx model. We get bounding box and angle from both, and we compare them. And sometimes we may use fixtures in similar scenarios. So we do not compare like Onyx to CoreML or some other inference engines, but we expect something very, very specific from our dataset. This test would help us to make sure that we did not change this train model pipeline unintentionally. Sometimes we have directional expectations. So we can introduce a set of perturbations to the input, and we would like these perturbations to have predictable effect to the model output. Like if we are doing house price prediction, we would like to be sure that increasing number of bedrooms while keeping all other features constant should not make the price lower. Or for example, when we lower the square footage of the house, should not increase the predicted price of the model.
Just have a question. So for
Sure.
in all these examples, so for this one and for previous ones, I guess we need to have like some sort of data set, right? Or some sort of like quite a few test cases. For example, for this one, we can have, I don't know, 1,000 records of different houses, and then for each of them we would do this kind of thing, right? And then we would run the test on the entire 1,000 data set, right? This is how you usually do this, or you do this by one example, one by one, or how does it look like?
I'm not sure that one is the good thing. I'm not sure if we always need 1,000 samples because, well, you cannot always do these changes automatically. Like with this example, when you replace like to don't like, you cannot do it completely automatically because sometimes like is a verb and sometimes it's not.
Yeah, for this you need to handcraft your test cases, right? But for the case
that is
with
right.
houses, yeah, probably.
For the case of houses, you can probably make it completely automatic, and thus you can have a wider test set to check.
But then, like the more examples you have, the longer times it takes, right? So you also need to balance like how long you actually want to wait. So maybe for local tests, you don't want to run the entire 1,000, but when you run on CI/CD, maybe you'll run it against a larger data set, right?
That makes sense. And also, I think it depends on the problem you are trying to solve because, well, running inference of a house prediction model should be fast enough on any machine. And if we are going about a pipeline like this, when we have to train model from scratch, even on Iris dataset, it takes a while. And if we are talking about training on a big model, some deep learning stuff, it's almost unreal. So you tend to have very simplified examples.
And by the way, so in this example that we just saw on your screen about then we retrain our model, it doesn't change the result. Yeah, this one. So what happens when the model actually changes the result? So we know that we just introduced something. We maybe added a few more lines to our data set. So we see now the result is 0.4, right? So what do we do in this case? So do we update the tests? Or?
That's a problem with tests that are very high level, like this one, because you need to maintain those and update the values. So this test is designed to validate if we did not change our train model function unintentionally. But if we changed it with some idea in mind, it is totally legit that score changes. And in this case, we may do some manual checks and say, well, I like my new train model pipeline. It is legit, and I will update the test as well.
Clear. So let's say we have a new flower that is not classified correctly. I don't remember what are those 3 classes, but let's say, yeah. Then maybe we add more data and we write a test that for this new flower, this should be the prediction, right? And then
that makes sense.
Yeah, and then when we add even more data, we want to make sure that this thing still produces this class, right? And if at some point it stops doing that, we will need to manually look into this and investigate why it's happening, right? And if we see, okay, it makes sense now, because it's kind of not clear what exactly this flower is, then maybe you can either modify the test or maybe remove it, right?
It could also save you in the situation when you update the library and you want to be sure that your libraries do not break stuff between versions. So like you have some expectations, but then you updated your XGBoost and your score changed significantly. And that's a signal for you. Like, well, do you still have robust models in the rest of your system?
Yeah, that makes sense.
Okay, one more engineering trick about this testing. As you mentioned, sometimes it's a problem of timing. If you want to do some tests on big data sets, it makes sense to use shallow networks as fixtures if you just need to have same property, but you don't need to have like exact representations. For example, I have some pieces of code that rely on real ResNet trained in some very specific conditions, but I would like to test that my code just keeps all these dimensions, keeps the shapes, etc., etc. So that's it, smoke test. But I don't want to run big ResNet on every smoke test. That's why I have this dummy ResNet. It's something that has the same input and the same output, like the API matches, and that's it. And of course, it's very fast. And this approach can be useful to end-to-end pipelines. This snippet of code is almost real, almost from my real code base. Say we have some big pipeline that is training semantic segmentation model. It takes a while, let's say, to do it from scratch on real data, requires GPU, and so on and so forth. So what do we do here? We take the configuration and we patch this configuration a little. So we only have 2 training samples instead of thousands, and we have only 1 validation sample instead of thousands. And we train it for 5 epochs instead of hundreds. And we run our big training pipeline, and we just check that our train loss is not too big, and our validation loss, again, sounds reasonable for this little data set. And this test, I don't know, takes something like 10 or 20 seconds on my CI, and it covers the whole pipeline. So it helps me to avoid stupid errors I introduce here and there.
So just to make sure that your model still converges, right?
Yeah, it still converges, and I don't have some, I don't know, some pre-processing. Yeah, like if I change some APIs and it doesn't even train at all. So we already mentioned about having some data sets as your tests, and it's not a new idea. And I encourage you to see this talk by Andrei Karpathy, how they use specific hard examples as tests for their machine learning models. Because for them in Tesla, it is very important to make sure, for example, that detector does not miss some partially occluded object. It's not about some fast tests running on CI, but I think it's still interesting thing to consider. Okay, we don't have much time, and I will just cover some additional things to think about when we are trying to build reliable machine learning software. So one thing is about assertions. Assertions are great in testing, but should not be used heavily in real code, in production code, because of 3 reasons. One is that assertions can be suppressed. They tend to provide not very verbose error message. And overall, our Python then says that we should prefer explicit to implicit. For example, here, if we have this more explicit check versus assertion, they effectively do the same, but the first one gives us a lot of context if needed, and the second one does not. And also you can run this Python code with specific flag to suppress your assertion. I don't know, I haven't seen anyone doing it in real life. It's very artificial example from my point of view, but maybe some of your colleagues would do it. So let's avoid some unnecessary risks. If you are speaking about runtime checks, we should think, what do we exactly check? Usually it's some input data format. For example, in images, we tend to check number of channels. We check how exactly they are represented, like is it batch, number of channels, heights, widths, or we have batch, heights, width, channels, or we don't have batch at all. We should check for data type, like is it, for example, unsigned int, or it's a float number. This we can also check for data range. And you can find some other domain-specific constants and invariance to check.
Like a yes, price shouldn't be negative, things like that.
Yeah, like this. Some more or less complicated example about our rotation world. So when we rotate image, we use some rotation metrics. And for rotation metrics, we expect it to have determinant equal to 1, because when it's not equal to 1, it means this matrix not only rotates the image, but also scales it. So that's why we can do this additional test. Does that make sense?
Yeah, I'm just trying to remember what rotation matrix is. But yeah, it does make sense. So just determinant, that's determinant is a word that I haven't heard in ages.
It happens in computer vision. And again, different languages, various languages may require various levels of runtime checks, because when you are working with some strong static typing, it can help you catching many errors in advance. And in dynamic typing world, you have more potential problems. So you could consider type hinting, something like this. Python has type hinting software named MyPy that helps to check if your types, if you annotate your code with types, are consistent. It's not a silver bullet. It doesn't help to catch all your problems. It may have some false positives, but overall, it's additional check that can be useful. One more thing, which is more high-level question to discuss, to think about, is about robustness and correctness. And again, I would like to refer to some example introduced by Steve McConnell in his Code Complete. Let's say we have video game and we have X-ray machine, and it means in these two examples, you would like to process potential errors in a different manner. So like if you have some problem in video game, you can just ignore it if it does not affect user too much. And if some object is not rendered in the video game, well, let's just try to avoid it. And in some X-ray machine, we don't want to have any problems ignored because it can lead to severe consequences. That's why we prefer to work with all errors in a very explicit way. And if something is going to go wrong, we should stop the work and displays the error, and so on. Let's talk a little bit about debugging. It's good when your code is defensive, but we need to be able to find some defects sometimes. They may be hiding. We need some investigations from time to time. And I would like to introduce some mental exercise. Let's say you're training some deep network on big data set. The training takes 2 hours per epoch. And after some almost random number of epochs, between 40 and 60, it fails with out of memory. What's your approach to solve this problem?
Get a larger machine?
Well, let's say you have the biggest machine possible, and it's still 2 hours per epoch.
Okay. Checkpoint it and then restart?
Well, okay, but I'm not sure if it helps, because if you just resume from your, I don't know, let's say 40th epoch, your error will happen on 18th epoch, because somewhere in your code you have a memory leak, and it takes your RAM bit by bit.
Yeah, adding print statements everywhere. I guess that's then seeing where they stop coming.
Okay, that is legit, but you don't know what exactly to print. And if you have this long training procedure, it means you will get your fast log after 3 full days, at least.
Yeah, I'm running out of ideas.
I faced such situations a couple times, and after solving them, I came with this protocol for myself. So first of all, we need to gather all related data, like see all the logs we have right now, all the problematic samples, if possible. Then maybe try to reproduce the problem locally. It's not always the case. Sometimes you cannot reproduce sync locally. I have been to situations when the problem is only affected by some production server, and you cannot reproduce it. And the next very important piece is to try to isolate your problem. And I know no other ideas other than binary search for this kind of localization. So, okay, if we have like training plus validation, and we expect that either training or validation has its memory leak, let's check one epoch with training, one epoch with validation, check some memory dumps. And if we see that after training, our memory consumption did not change, but after validation did, okay, here we go. Let's do the validation bisecting. And after sync is more or less isolated, you can iterate with hypothesis what exactly could go wrong, like what pieces of code are suspicious and how you could fix it. And as I mentioned, logs are very important here. Overall, logs are one significant part of your monitoring strategy. Good monitoring helps you to be alerted when things break, to know what's broken and why broken. Logs can help you inspect some trends over long time frames, and maybe compare system behavior across different versions, different experimental groups like in A/B testing world, and so on. Some good practices about logging. If you are not sure whether you should log or not, it's better to log. You will remove it later if you realize that those logs were unnecessary, but it doesn't work in vice versa. You cannot retroactively add logs on some past events, and try to add new context in your logs. So instead of just typing rotate the image, it makes sense to add additional information, like we rotated the image that was loaded from this image path, and the angle we used is X. Okay, about monitoring, I think we are almost out of time, so we will not cover it much. I will just highlight that comparing to regular software, like ML software tends to be broken in unexpected way. So like you usually do not expect that some regular software is broken without code changes or significant input data changes, but ML software is often very sensitive to small distribution changes like seasonal change, trend change. For example, users started using new cameras or new microphones when they input some visual or audio data, and it can be very significant. So just two very short conclusions. Don't avoid monitoring input and output data distributions, model confidence, and so on and so forth. And when you are considering between robust, like strongly regularized model or potentially overfitted model, always choose the former one. Also, I recommend to look at this article that covers the idea of concept drift if you are not familiar with one. Okay, I think that's mostly it. I have some links related to general software testing. I recommend some articles and books, and also some stuff related to machine learning only. Again, articles and videos. And that's it. That's it. And we still have a little amount of time if we have some additional questions or something else.
Yeah, will you tell us how to actually solve that problem with a big machine that dies with out-of-memory errors?
Well, I spent something like 4 days in this dissecting approach. So I couldn't reproduce it completely. So instead of reproducing the whole thing, I added some loggers that store memory usage, that like save memory usage to over time. And I ran like one epoch. And after one epoch, I realized that, well, training does not affect memory usage significantly, but validation does. And then I ran validation, and I tried to run only subsample of metrics because it was a complicated pipeline with something like 6 losses and 4 metrics. And I realized that not all metrics affect this memory consumption. And there was one specific metric that required non-maximum suppression to be calculated. And this non-maximum suppression was written in PyTorch. PyTorch had some very specific memory leak related to reshaped tensors. And after I replaced these tensors to copy of tensors, the leak was gone.
That's like, did you feel like a detective after that?
I did.
Looking
I
at all
definitely
these
did.
cues. Yeah, that's an interesting story. Yeah, thanks for sharing that. Yeah, we have some questions. So one question is about a book. So can you please maybe let me share my screen so that it's easier for you to read the question as well? So the question asks, can you suggest some resources on testing ML systems? I have been a software tester for 16 years and now exploring machine learning testing. I think you showed us a bunch of links. Maybe now let me stop sharing my screen and then you can share yours because I remember like you had a few resources there, but I don't know how many of them are useful for testers.
I think many of them are. I would just recommend to look through them. Maybe, I don't know, this TensorFlow maybe a little too complicated, but things like this beyond accuracy and proper checklists are somewhat useful. So overall, this list is not too big. I would recommend to go through it and check what is relevant to your background and your skills and what is not too much. So these slides will be shared, I believe, right?
Yeah, I already shared the link because you gave me the link before the talk, so I already put it in the
Nice.
description.
So I can only recommend to go through these links.
Have you heard about this role of machine learning quality assurance engineer or some sort of like not standard, traditional quality assurance engineers, but ML specific ones?
I know about data quality engineers role, but haven't seen machine learning quality engineers yet. And as for data quality engineers, I only heard about them, but never worked with such roles in the team. I tend to work in smaller companies, and in small companies, it is usually this role is the same as machine learning engineer role. You do your own quality assurance.
I actually haven't worked with a quality assurance engineer for quite a while. I don't know why. In Berlin, it's just not a popular role. I guess software engineers are expected to test their software themselves, and the same, I guess, happens with when it comes to machine learning.
I believe it makes much sense. Maybe for some UI, you may need more manual work, but if you are talking about backend systems and machine learning systems, it is really useful when engineers do this testing on their own and keep it in mind.
Do you have more time now, or
Like for a couple more questions?
Yeah, so I have a question, but it might
Of course.
be okay.
Yeah,
So
I have 10 more minutes. Yeah.
Okay, good. Because you mentioned that we're running out of time, I just want to make sure that we still have a couple of minutes. So I wanted to ask you, so let's imagine that I am a data scientist and I wrote my Jupyter notebook where, let's say I trained a Keras model or I don't know, PyTorch model. So I did all that in the Jupyter notebook. And now I want to, let's not take Keras because maybe this is a complex example, start with simpler. So let's say XGBoost, right? So now I want to productionize this XGBoost. I want to take this notebook and put it to a Flask application, take this notebook, export it to Python, and then put it to Flask or FastAPI or whatever. So what would you recommend? What kind of best practices I should follow to make sure that my code is reliable while doing that?
Okay, I think we should start with some higher level tests and then introduce something more complicated. So first of all, let's write our very first test. It will be a smoke test with something like, I don't know, let's say we only have model, and for this, we only have some training stuff. And for training, we should introduce tests like
A lot of
this.
slides.
Yeah. So we can have this end-to-end training test that checks that things are not broken. After we have at least one test, it's required to introduce some CI. So once we are working with this code, we always run our tests. Maybe the next important test would be about these exact values. So something like here. So we train on some small data set and we always have the same score. And then we start some productionizing, like we introduce this Flask API. And if we already have API, it would be useful to add some non-ML specific tests, but something like this. So we send some request and we have some response. And as we have CI with tests that cover the ML stuff more or less, at least on some high level, we can be sure that we interconnect correct sync to correct sync. And if we have some time, we can go to the bottom of this test pyramid and switch to more atomic, more isolated, lower level tests.
Oh, thank you. Do you know any open source project that implements that could be a good example for somebody who, let's say, wants to learn how to do tests?
I'm not sure right now. It's a good question.
Because usually you learn this at a company, right? At a company, you see how people do this. But yeah, I'm wondering if there is a good, because I don't know one. I would love to find something like that and use this as an example.
Yeah, I believe the problem is that open source projects, like machine learning open source projects, they can be libraries, let's say, and libraries have a wide coverage of unit tests, but not much end-to-end tests, not many end-to-end tests, and some pipelines like, I don't know, Kaggle solutions or something like this, they usually have no tests at all. Yeah, and this integration test is something that is more useful for companies. No idea, unfortunately. I'll think about it.
If you come across something, or anyone who is watching this, if you come across something or if you know something, please let us know. Okay, I do not have any questions. I do not see any questions in Slido or live chat. Yeah, by the way, there was one suggestion to the problem of out of memory leakage was to reduce batch size. I don't know if it will solve the problem completely or just kind of postpone it.
Well, it's not a solution, I believe. It's a hotfix, which could help, but you still have your buggy code with your memory leak in your metric in this case. So yes, it's a short-term solution, but you cannot rely on it.
I think all the solutions I proposed were more, workarounds rather than actual fixes. Like, get a bigger machine. But sometimes it works, right? But up to a certain extent.
Yeah, sometimes you can do it.
Okay, I guess that would be it. So we do not have any more questions. So thanks, Arseny, for joining us today, for sharing your knowledge with us. That was very useful. And thanks everyone for joining us today as well, for watching. Yeah, I guess.
Thank you. It was fun.
By the way, how can people find you if they have a question?
I have some contacts since the very beginning.
Yeah, right.
Of my slides,
email, and then Telegram channel.
Yeah, that's right.
Yeah, so that's the email. Great. Okay, thanks a lot, and have a great rest of your day.
Yeah, you too. Bye.
Great.